Students, welcome back to my channel. Today we'll study the topics of dynamics. That is, I will give you a detailed summary basically of formulas which would be useful in dynamics, the subject taught in university level as an optional subject. Now let's get started.
Now, let's talk about projectiles. Basically, like this. Moving with velocity u. This is its range r, keeping an angle alpha. Greatest height attained is h. First, we see that m d square x over dt square is 0. And in vertical direction, it is moving under gravity. M d square y over dt square is equal to minus mg. From these equations we have that initial velocity is u cos alpha in horizontal direction and u sin alpha in vertical direction. We also have that velocity at any position is u cos alpha in horizontal direction and u sin alpha minus gt in vertical direction. From here we have that x is equal to u cos alpha into time and y is equal to t u sin alpha minus gt square by 2. Integrate these two with respect to t. We get equation of motion which is of a parabola, that y is equal to x tan alpha minus gx square secant square alpha 2u square. To see it more clearly that it is a equation of parabola, we do x minus u square sin alpha cos alpha. Multiply the equation by 2u square over g secant square alpha whole square is equal to minus 2u square cos square alpha over g into y minus u square sin square alpha over 2g. Then we get, if we take this quantity to be h and this quantity will be k, then vertex of the parabola is h by k and this quantity is L, latest rectum. Focus which we get is u square sin 2 alpha over 2g minus u square cos 2 alpha over 2g. Height of directrix we get is u square over 2g. Basically by this k plus L by 4 is the formula. Now in this case time of flight is 2u sin alpha by g. Horizontal range r is u square sin 2 alpha by g, which is maximum when sin to alpha is 1, that is alpha is equal to 45 degree. And we have same horizontal range at two angles of projection, that is alpha and pi by 2 minus alpha. Greatest height attained is u square sin square alpha over 2g. We also have a property that velocity at any point of path of projectile is same as acquired in falling freely a vertical distance from directrix, least velocity of projection to hit a given point AB is under root G B plus under root A square plus B square. Projectile motion over inclined plane upwards. This is beta. Angle of projection is alpha. This is velocity u, and this is range r from here to here. Then range is equal to 2u square sine alpha minus beta. Alpha is still here. Cos alpha over g cos square beta. Range maximum is u square over g 1 plus sine beta for alpha equal to pi by 4 plus beta by 2. Time of flight is equal to 2u sine alpha minus beta over g cos beta, and for a particular range we have two angles of projection, that is alpha and other is pi by 2 minus alpha minus beta. Now inclined plane down, projection down the inclined plane, range r is equal to 2u square sine alpha plus beta cos alpha over g cos square alpha. In down case, just change beta to minus beta, and the same formulas will apply for down case. In upwards case, change beta to minus beta. So time of flight is equal to t2u sine alpha plus beta over g cos beta. R maximum is equal to u square g 1 minus sine beta. Motion in a horizontal circle if OP makes an angle theta radians with a fixed line OX, it is a horizontal line, in time t, then angular velocity of P about O is given by d theta by dt. Angular acceleration alpha is given by d omega by dt, that is d square theta over dt square, or omega d omega over d theta. Angular velocity of P about O is also equal to linear velocity of P resolved perpendicular to OP over OP. If P moves about a circle, then omega is equal to V over R, where r is the radius of the circle, v is the linear velocity, and omega is the angular velocity of p about the center of the circle. Now, equations of motions under uniform angular acceleration are omega is equal to omega naught plus alpha t, theta is equal to omega naught t plus alpha t square by 2, omega square is equal to omega naught square plus 2 alpha theta. T implies time, alpha is angular acceleration, omega naught is initial angular velocity, and omega is angular velocity at time t. 1 rounds per second is equal to 2 pi radians per second. Tangential acceleration is equal to dv by dt, that is v dv over ds. Normal acceleration is equal to v square over r, or r omega square, and hence acceleration is equal to under root normal acceleration square tangential acceleration square. Conical pendulum diagram moving in a circle. This is tension T, this is weight mg, height h, length L, angle alpha. Then T cos alpha is equal to mg, T sin alpha is equal to, in this direction, mr omega square, basically ma acceleration, and we know that cos alpha should be less than or equal to 1, which in turn implies omega square should be greater than gl for conical pendulum to move. Now, in rotating sphere, also we have same kind of diagram. R cos theta is equal to mg, and r sin theta is equal to mr omega square. Now, let's talk about motion in a smooth vertical circle inside, outside. Now, in inside case, let's first see the diagram. This is reaction R, weight mg, this is angle theta, N O A. Then equations along the tangent, we have m v dv over ds acceleration is equal to minus mg sin theta. Hence we can calculate that v square is equal to u square minus 2gh. But we substitute the value of h equal to 1 minus r cos theta. Then we get u square minus 2gr plus 2gr cos theta, and in normal direction r minus mg cos theta is equal to mv square over r. Normal reaction, r is equal to m over r u square minus 3gh plus gr. Again, if we substitute the value of h, then we get m over r u square minus 2gr plus 3gr cos theta at highest point, that is for H equal to 2R, we have reaction is equal to M over R u square minus 5gr, and hence it will have complete revolutions if u square is greater than or equal to 5gr, and it will oscillate on each side of the lowest point if u square is less than or equal to 2gr. It will leave contact with the circle if u square is in between 2gr and 5gr. Now, in this case, it moves with the in a parabola under the effect of gravity. These all equations are true in case of if we take a heavy particle tied to one end of light inextensible string of length L, whose other end is fixed, projected horizontally with a given velocity u. We can take small r to be L in that case, then inextensible string case. Now motion outside a smooth vertical circle diagram. O reaction R mg sin theta mg theta is this. This is height h am. Now b square is equal to 2gh. We can calculate mg cos theta minus r is equal to mv square over r, and hence we have that r is equal to mg over r minus 3h. R is equal to 0, leaves contact with the circle at h equal to r by 3 and theta equal to cos inverse 2 by 3, as h is equal to r minus r by r cos work, power and energy. Work. A force is said to do work when its point of application undergoes a displacement equal to F into displacement in the direction of force, therefore cos theta. Units are joule, foot pounder. Conversions previous lecture में मैंने बता दी थी इनकी. Now it is also equal to, in case of a variable force, F dx. In CGS units, ergs is also a unit of work. Now, Hooke's law also I have already discussed. Work done in stretching an elastic string we have is extension into tension by 2, also equal to extension into mean of initial and final tensions. Now power is rate of doing work over time. SI units is watt, 1 joule per second. Horsepower is also there. If it is doing 3,000 feet pounds of work per minute, or equal to 550 foot-pounds per second, 746 watt. Power per formula is also equal to force into velocity. Kinetic energy is the capacity to do work by virtue of its motion, equal to half mv square. Potential energy is the capacity of body to do work by virtue of its position, equal to mgh. Principle of work and energy states that change in kinetic energy is equal to work done by the forces. What do you mean by conservative force? Which does not depend upon path and depends only on initial and final positions. And in effect of conservative forces, we have conservation of energy. We state that kinetic energy and potential energy remains constant. Now impulse is equal to force into time, also equal to change in momentum, integration f dt. We have principle of conservation of linear momentum. In case of motion of shot and gun, if capital V is the velocity of recoil of gun, then V is equal to mu or capital M, mass of the gun, mass of shot, velocity of shot. Now let's talk about collision of elastic bodies. We have Newton's experimental law, which states that the relative velocity after the impact is negative of constant of elasticity or restitution into relative velocity before impact. Now, impact of smooth sphere against a fixed plane diagram is a circle. U, V, alpha, this is angle theta. Then V cos theta is equal to EU cos alpha. Using this, V sin theta is equal to U sin alpha, because velocities in the direction perpendicular to the line of impact does not change. Hence, we can find V by squaring both the equations and adding it, and also we can find angle theta by dividing the equations. Loss of kinetic energy is always there, which is half mu square 1 minus e square, because e is always less than or equal to 1 cos square alpha. Impulse is equal to um 1 plus e cos alpha. Now we take the case when two smooth spheres impinge, that is, they collide directly And we have another case, obliquely at an angles. So let's discuss directly. Mass m, m dash, moving velocity u, u dash, after impact v, v dash. The linear momentum is conserved, so mu is equal to m dash u plus is equal to mv plus m dash v dash. And now by Newton's experimental law, v minus v dash is equal to minus of e, u minus u dash. In this case also kinetic energy is always lost. Sorry, perfectly elastic. In that case E is 1 and loss of kinetic energy is 0. Now if two spheres oblique impact, in that case diagram, U1 mass into angle alpha, angle theta, angle beta, angle phi, V2, V1. Then in this case we have that first let's notice that in perpendicular direction to the line of impact there is no change, so v1 sine theta will remain equal to u1 sine alpha and v2 sine phi will remain u2 sine beta. In the direction along the line of impact we have that angular momentum is conserved, so m1 v1 cos theta plus m2 v2 cos phi is equal to m1 u1 cos alpha plus m2 u2 cos beta, and by Newton's law we have that v1 cos theta minus v2 cos phi is equal to minus of e u1 cos alpha minus u2 cos beta. Let's talk about relative motion. In above case we also have that ratio of impulses of forces of restitution and compression is E. In relative velocity of P with respect to Q is equal to relative velocity of P minus velocity of Q, velocity of P. Now to compute, if V is moving in direction beta and U is moving in direction alpha, and we have to find relative velocity V, with respect to U, then we resolve it perpendicularly in mutually perpendicular direction. So we get V cos theta. Theta is the angle which capital V makes the relative velocity equal to, जिसकी हमें रिस्पेक्ट में चाहिए वो माइनस में आता है, V को चाहिए तो V यहाँ आएगा, V cos बीटा माइनस U cos alpha, and perpendicular direction में V sin theta is equal to V sin beta minus U sin alpha. इन दोनों equations को add by squaring and adding we can calculate E, and by dividing we can calculate it theta.